Okay, so here are the notes. So 3.1 is on interpreting graphs. So let's go ahead and look at this launch. It says, what is the real meaning of this graph, which shows the relationship between the number of customers getting a haircut each week and the price charged for each haircut? So can somebody explain what does this graph mean when you look at it? Davey? Yes, nice explanation. Do you understand that as, and I like how you explained that, as the number of customers goes down, or maybe let me restate that. I think let's state it like in the reverse. As the price of a haircut increases, the number of customers decreases. So I'm not sure if any of you ever go to Great Clips, but when they have their $5.99 haircut, you see it's super crowded. The price went down, so they have more customers. So we did our little partner activity. What does the slope represent here? So let's put the slope, we said rise over run, the change in the y over change in x. But when you have a real world problem, like what does the slope actually represent here? Yeah. Yes, it's the price of a haircut over the number of customers per week. So it is oh wait, don't I have that backwards? Yeah, it is the y over x. Sorry, we just cut that. Yeah, the slope is going to be, thank you, the number of customers each week over the price of a haircut. Yeah, because it's really the difference of the x's, or difference of the y's over the difference of the x's. All right, what is the meaning of the intercepts? So you have an x-intercept. So what does it mean here? An x-intercept is what's this value here? Like in context to the problem, what would this number here on the x-axis represent? The price of a haircut at what? Yeah, so really, wouldn't that be the price of a haircut that nobody's willing to pay for? Right? Okay, so that is the price of a haircut no one is willing to pay. All right, then there's always on a graph an x-intercept and a y-intercept, which you learned in Algebra 1. So what would the y represent? The y-intercept? Yeah, Charlotte. The most customers, and then what's the price there? 0. Okay, so this is the number of customers. So the y-intercept represents the number of customers who come in and get their haircut when the haircut's free. It's no cost. All right, then the last question here, is this a linear relationship? Does this look like a line? Yes, it does. The graph is a line. All right, so now let's take another graph. In example 1, it says students at Central High School are complaining that the juice vending machine is frequently empty. Several student council members decide to study this problem. They record the number of cans in the machine at various times during a typical school day and make a graph. So let me point out information on the graph. So in the morning, this is 7 a.m. Normally it would start at 6 a.m. 6 a.m. to noon, and then this is like 1 in the afternoon, 2 in the afternoon, and so on. And then on the y-axis, this is the number of cans in the juice machine. So when it hits the x-axis, that's when it was empty, okay? And then full, you can see there's periods of time where it is in fact full. I'm going to give you a couple of minutes head start on me, and I want you to try to answer these questions, A through E. right, discuss at your tables. What did you guys say for A, B, C, D? And if you got the E, great. Okay, discuss at your tables. What did you get?
Since I was there, there's so many different times, so I just took everything like that. Well, because it also isn't empty at 7, 8, and 9.
Okay, let's go ahead and talk about these and see if we can interpret the graphs. So let's kind of look at this. So when the graph is coming down, what does that mean? People are drinking the juice, right? Okay, so it's like coming down. And so what does it mean from 7 to 8 o'clock? You see how steep of a drop that is? And then from 8 to maybe 10:30, it's not decreasing as much. So what do you think is happening at a school between 7 and 8? They're just getting there. They're starting to drink before school starts. Then people might be able to pass it between classes so there's not as many access. Then what happened from 10:30-ish to a little before 11? What happened? They refilled it, right? Then what happened where it's horizontal? Probably during a class period, right? They couldn't go and get it. All right, whoa. And then what do you think's happening here between 11:30 and 12:30? Lunch. Okay, all right, so hopefully we're getting the hang of this. So, based on your graph, what times is juice consumed most rapidly? Well, it definitely happened between 11:30 to 12:30. And there was another time that there was a really big spike. Where else? Yeah, how about 3 to 3:30? All right, when is the machine refilled? And so say it again.
4 to
Okay, definitely at, yeah, it looks like at 4 o'clock. And that's probably the, yeah, end of school day, after school. All right, isn't it refilled a few other times? Didn't we say it got filled at 10:30? And then, and isn't it also happening a third time? Yeah, sometime overnight, right? Because all we can see is after 8 or 9 o'clock, it's leveled off, and then it's full in the morning. So, I mean, you could say 6 a.m. is okay. Maybe that's when it got restocked. All right, when is the machine empty? So Zoe, when did your group say the machine was empty? Okay, great. Just after 12. So maybe 12:30. I couldn't quite tell. And then it was empty again from 3:30 to 4. How can we tell? Yeah, Sydney?
It's all the way at the x-axis on it.
Yeah, okay, so couldn't we say the y value is 0?
Yeah.
Yeah, okay. What do you think the student council will recommend to fix the problem? Now, this is an opinion question, okay, so there isn't a right or wrong answer on this. What do you think student council could recommend? Okay, so one recommendation is bring your own juice or drink. What's another recommendation? Yeah, Angelo? Okay. All right, Lilia, did you have another idea?
Yeah, I feel like it's some students to do something like different time.
Awesome. Yeah. Yeah, Sydney?
Just get another machine.
Oh, get another machine. Yeah, because clearly there's a demand, right? Now, something else that nobody quite mentioned is, do you see, and I think it was, maybe it was implied there, is do you see here when they filled at like closer to 1, they didn't restock it, did they? It's like, well, why didn't you restock it all the way? You know? Order more. You could refill more often, restock completely, get another machine, bring your own drinks. That would reduce that. All right. So now let's look in letter E, and you may or may not have gotten all the way to here. It says, look at this graph at the right. How does the graph at the right depict the same information? So looking above, so from 6 to 7, it was full. But then now, what did they do here to change the graph? Yeah, Lilia?
They added a line after the
What do you mean they added the line after that?
They have the first whiteboard, and then they have like the second whiteboard, and the third, and so on.
Yes, they've definitely done that. So instead of it being like continuous, they have where it's maybe by number of cans, maybe? Number of cans of juice are really only whole numbers now. All right, so, and really, this isn't going to feel so much like math when it really is math that we're doing, is I'm trying to lay a foundation here of why we look at functions. Like if you are a principal at a school or you're the coordinator of the vending machines, like these are things you're going to look at trends, when to restock, all that sort of stuff. All right, here's a little investigation, and then I believe that wraps us up. It says, you have probably experienced filling a thin water bottle and seeing that the water level rise quickly, or filling a wide bucket and seeing the level rise slowly. What if the container changes shape? How will the water level change over time? The shape of the bottle gives clues about the graph, just as a graph of water height versus time can give clues about the shape of the container. If this bottle were filled with water at a constant rate over time, a graph of the water height over time would look like this. So do you see that this is a straight cylinder? So this could be, just a container of water. You could think about like soda or pop in a can, a juice bottle, all sorts of different kinds, soup cans, things like that. Okay, so there's a lot of real world applications. But imagine if we were filling the water, it goes up consistently, right? And so this is the graph. I'm going to give you a couple of minutes, and what I want you to do is I want you to try to match the container on the left to, if you were to plot the time over the height, which one would it go to? So this is a little matching. So I think this one is easy enough to do letter A. That's going to go with 3. All right, now I want you to discuss at your tables. Have one person read off the answers, but I want you to explain why it went with its figure. Go ahead and discuss.
That's what I meant. I didn't make 3, 2, 0. Sorry. Yeah, the shape. Obviously, this is why is it not bringing in C? It's gonna go
Okay, so one, it took longer to fill up, so because it's a bigger base than C is, so it won't be as quick as number 1. Like quick, number 1 line goes up a lot quicker than C. That's actually quick. So that's
All right, so letter B, which letter did that go to? Did it go to I or double I? Lilia, what do you think? You thought it was double I?
yeah. Oh wait, no, it was I.
Yeah, I was like, wait, I had I.
My iPad's kind of frozen right now.
Oh, okay, yeah. So, and then this one went to double I. And so let's kind of talk about this if you got these wrong. It takes a little bit of getting the hang of this. Is that, do you see in letter C? This is a really, really wide base. So that means when the water's first coming, the height goes slowly. Then as it widens, then it's going to go faster. So this one goes slowly at first and then starts to increase. Here, this one is going to go a little bit faster, then slower, then faster, and even faster. Okay? So this one had a little bit of a change in how fast the height was filling. All right, any questions now on that?